Hello everyone, I welcome you all in this C programming and data structures lecture. This is part 7 of application of stacks infix to postfix conversion. So without any further delay, let's get started. We know that this algorithm works. This works for the conversion of infix to postfix expression, right? We are done with all these three parts. That is, we have handled all these three cases. If symbol is an operand, if symbol is a left parenthesis, if symbol is a right parenthesis. This is what we have done in the previous presentation. We have actually converted all these three cases to its equivalent C program, right? But we are left with this part. That is, if symbol is an operator, then what to do in that case, right? We have to handle this case as well. For this purpose, we will include this in our program as well. If symbol is an operator, then what to do, right? This is a very important step. In this presentation, we will try to write a C program for this case as well. If symbol is an operator, then what to do? We will handle this case as well. Okay? If symbol is an operator, then do the following. But before doing all these things, we first have to include this case in our program, right? We know that this is how our program looks like, into post. And in this function, I have handled all these cases. You can see this, that we have a left parenthesis, we have a right parenthesis, and we have a default case. Default case will get evaluated if the symbol is an operand, okay? Not an operator, but an operand, okay? So this is very important case. Of course, this default case must be evaluated after that. But what about the operators? We have to add these cases as well. Plus, minus, multiply, divide, and power. I'm considering these operators only. There are other operators as well, but for this presentation and for the simplicity's sake, I'm considering these operators. Plus, minus, multiply, divide, and power. Okay. So we have to handle all these operators and have written them one by one. Over here you can see this. And what I'm going to do, I'm going to write the code after this case. That code will be applicable to all these operators. This is how switch case works, right? If you have any doubt about this, then watch the C programming lectures on switch case as well. Okay. Now here, if the symbol is an operator and if it is the case that precedence of the operators in the stack are greater than or equal to the current operator under consideration, right? If it is the case that the precedence of the operators in the stack are greater than or equal to the current operator, this means we have to check the precedence of the operators in the stack and we have to check the precedence of the current operator, right? And we have to compare them. If it is the case that the precedence of the operators in the stack are greater than or equal to the current operator, then pop the operators out of the stack and store all the operators in the postfix array. Previously, we were doing this. Pop the operators out of the stack and print them onto the screen. But this time we have to do this. Pop the operators out of the stack and store all the operators in the postfix array. I have already told you the reason behind this. Because later on we have to evaluate our postfix expression as well. We can't simply print the whole postfix expression onto the screen. We have to store it somewhere, right? So this is important. That's why we will not only pop the operators out of the stack, we will store them onto the postfix array. And later on we have to push the current operator onto the stack as well, okay? This operation, that is pushing the current operator onto the stack, is mandatory. We have to do this. In the else part also you can see push the current operator onto the stack. We have to do this no matter what. So we can write just one thing and then after this we definitely have to push the current operator onto the stack, right? So this is a mandatory step. Now you can see the current requirement. If the precedence of the operators in the stack are greater than or equal to the current operator, then pop the operators out of the stack and store all the operators in the postfix array. Else simply push the current operator onto the stack, right? We are already aware about this. Let's do the whole procedure. And definitely this part, that is pushing the current operator onto the stack, must be evaluated no matter what, okay? We will also check whether the stack is empty or not. This is a very important step. We have to check this as well, that whether the stack is empty or not. If it is the case that stack is empty, then simply push the operator onto the stack. Otherwise, continue with the procedure, right? So here we will use a while loop and we will check all these things. These two things actually. First we'll check if the stack is empty, then we'll get outside of this while loop. Otherwise, we'll continue. And precedence of stack top. If it is the case that precedence of stack top is greater than or equal to precedence of the symbol, that's what we have to check, right? If the precedence of operators in the stack are greater than or equal to the current operator, That is what I'm checking over here, right? Now you might be wondering, what is this precedence, right? What is this function? We have to define this function, but think of this as a black box. This precedence function will take this input. Here in this case, it is taking stack top, which means the topmost element of the stack. And it will return some value, which is the indication of the precedence, the priority of the operator. Here we are checking the priority of the operator, and here we are checking the priority of the current operator under consideration. That is the symbol we are talking about, right? So we are checking the precedence of the symbol, and we are checking the precedence of the topmost element of the stack. And we'll continue to do this for all the elements of the stack. That is, all the operators of the stack. If the precedence of the topmost element of the stack is greater than or equal to the precedence of the symbol, then please do the following. Pop the topmost element of the stack, that is the topmost operator of the stack, and put it inside postfix array. Simple. And later on, we definitely have to push the current symbol onto the stack, right? And this break statement is also required. You can write this in the next line, or maybe you can write it after this push symbol, that is this function, okay? So this is not a problem at all, but you can understand this, that how this while loop works, right? Here we are checking the precedence of the topmost element, and here we are checking the precedence of the current symbol. If it is the case that the precedence of the topmost element is greater than or equal to the precedence of the symbol, then pop the operator out of the stack. Pop the topmost symbol out of the stack and put it inside postfix array. And after completing this whole procedure, after doing every iteration, we'll get to this point, that is push the current symbol onto the stack. Fine. Now this is how our precedence function looks like. Now it is quite clear that here we are using a switch case because we have to handle all these different cases, right? Switch case is obviously better than if else, if we have multiple conditions to check, right? Here we are giving the priorities to each operator, and you can see this over here, the power operator has the highest priority. Now this is something different. Here I've put this comment, higher value means greater precedence, which was not our previous assumption, right? We were thinking that the lower value means greater precedence, but now I'm considering this that higher value means greater precedence. Although you can go ahead with lower value, but you have to change the condition in the function as well, that is into post function. There greater than or equal to becomes less than or equal to, right? Here it is making sense, higher value means greater precedence. So power has the greatest precedence because it is having the highest value 3. Divide and star has the value 2, plus and minus has the value 1, and default, that is if there is some other operator, it has the least precedence, okay? Now I think it is clear to you that how to set the priorities to the operators. Fine. And here you can see that the precedence of the topmost element is checked. It might be possible it is a power operator. In that case, we will get 3 over here. And it might be possible that the current symbol is divide. And we know this, that the priority of the division operator is 2. We can clearly see this, that 3 is greater than 2. Therefore, we'll get inside this while loop. It is making sense, right? And this is it. We have handled these cases as well, right? Now, after this for loop, we have to add one more piece of code. While not is empty. If the stack is not empty, then continue and pop the operator out of the stack and put it inside postfix array. It might be possible that after completion of this for loop, we will be left with some symbols inside the stack, right? Therefore, we have to put this piece of code. While stack is not empty, do the following. And at last, we have to put \0 at the end of the postfix array. This is very, very important. This is the end delimiter, right? We have to put this at the end of the string. Fine. So I hope this whole code is clear to you, and this is all we have to do in the into post function. This is very, very important, right? Now, let's consider one example. Let's say we have the following infix expression, and our task is to simply convert the following expression to its equivalent postfix form. Okay, so this is the expression we are available with, 7 plus 9 minus 5 into 2. Okay, this is the infix expression, and our task is to simply convert this expression to its equivalent postfix form. Let's do this with the help of our code. First, we know that the execution starts from the main function. Here, of course, the message will get printed on the screen, enter the infix expression, and user will enter some infix expression. And we are assuming here that the expression is 7 plus 9 minus 5 into 2. This is the expression entered by the user. We'll simply put this inside the infix array. You can see this how our infix array looks like after inserting all these symbols onto this array, right? Now we will simply call this into_post function for the purpose of converting the infix expression to its postfix form, right? Now in this into_post function, these 4 variables will be declared, right? You can see them over here: I, j, symbol and next. After this we have a for loop, and here I is initialized to 0, right? After this we'll check this condition: is I less than str length of infix. That means we are checking whether I is less than the string length of infix array or not. What is the string length of infix? Obviously it is 9, right? You can see this, that there are total 9 elements in this infix array. Actually, we have to exclude this \0, okay? This must not be included. You can see this from here to here, the total 9 characters in this infix array. That's why the string length of infix is 9, right? So we can easily replace this strlen infix by 9. And here we are checking this condition: is I less than 9? Yes, 0 is less than 9. So we can continue and we can get inside this for loop. Symbol equal to infix I. What is infix I? I is 0. What is infix 0? Infix 0 is this character. So we'll put this character inside the symbol variable. After this we have a switch case. We know that this is our symbol. This is an operand as well. So default case will be evaluated, and definitely this symbol will get inserted inside this postfix array, right? This j++ will get replaced by 0, and definitely after this symbol will be inserted inside this postfix array. This is how our postfix array looks like. And definitely after this j will get incremented by 1, because this is j++, post increment, right? First the value will be replaced and then the increment will happen, right? Now after this we'll get to this point, I++, I will be incremented by 1. Then after this we'll get to this point: is I less than 9? Yes, definitely you can see this I is less than 9. We'll get inside. We'll put infix of I, which is infix of 1, inside symbol. Now what does it look like? Obviously infix of I, infix of 1 is plus this character, right? Okay, so we will put this inside this symbol variable. Then again we have a switch case, and we know that this case will get evaluated, right? Because right now we are having an operator. Now we will go ahead with this while loop. Is stack empty? Yes, stack is empty. Therefore this becomes false. And false and with anything is always false. So we will get outside of this while loop and we'll get to this point. Push the symbol onto the stack. What is the symbol? Symbol is this plus operator. So we will push this symbol onto the stack. This simply means we are pushing our operator onto the stack, right? So this is how our stack looks like, and we will push the operator onto the stack. Now let's continue. After this we have to break outside of this case, and then we will land at this point again. I++, I will get incremented by 1. Then after this we'll check this condition: is I less than 9? Yes, I is less than 9. So we'll get inside. Again we will obtain some symbol. Infix of 2 is this symbol. We'll get a left parentheses, right? So we'll put this over here in the symbol variable. Then again we have a switch case. Now this time we'll encounter this case, that is left parentheses case. We have to simply push this symbol onto the stack, right? So let's push this symbol onto the stack. Then we have to break out of this case. Then again we'll land at this point. This becomes 3. This condition is again satisfied. We will land at this line, and definitely this time we will need infix of 3. What is infix of 3? Infix 3 is 9. This symbol. So we'll put this symbol in the symbol variable. Then again we have a switch case, but this time default case will be evaluated, which means that we will simply store our symbol inside postfix array, right? And here we know that value of j is 1. So this will get replaced by 1, right? And obviously this means that this symbol will get stored at this position. And definitely after this j will be incremented by 1. This becomes 2. Now let's continue. And here again I will be incremented by 1. This becomes 4. We'll again check the condition. Condition is satisfied. This symbol variable will now receive this character. So we can replace this by minus. This time we will check this condition. Is stack empty? Stack is not empty. So this is true, right? Now we'll check this part of this line of code. Precedence of stack top greater than or equal to precedence of symbol. We'll check the precedence of the topmost element of the stack and the precedence of the current symbol, right? What is the topmost element of the stack? You can see this over here. This is the topmost element of the stack, right? That is the left parenthesis. We will check the precedence of this left parenthesis. After this, we will check the precedence of the current symbol. We know this is minus, right? So what is the precedence of the left parenthesis? Precedence of left parenthesis is definitely 0, because we know that if we have any other operator apart from this, then this default case will be evaluated and eventually we will return 0 from this function, which means that the precedence of the left parenthesis is 0. Fine. So here this precedence function will receive 0, and after this we'll call precedence function once again, but this time we will pass this character to this precedence function. Let's check the precedence function once again. You can see this, that this case will be evaluated and we will return 1 from this function, and here this caller will receive 1. Is 0 greater than 1? Is it true? No, it is false, right? Therefore, this condition becomes false. This whole thing becomes false. The precedence of the topmost element of the stack is actually less than the precedence of the current symbol. That's why we can push this symbol onto the stack, right? Therefore, this statement will be evaluated. We'll simply push the current symbol onto the stack, right? After this, the next step is to break out of this case. We will land at this point, I++. This becomes 5. Then again, we'll check this condition. Condition is satisfied. We'll get inside. Now we have infix of 5. What is infix of 5? Infix of 5 is this character. We'll place this character in the symbol variable. Again, the switch case will be evaluated, right? Now we have an operand. This default case will be evaluated. Now we'll simply put this symbol inside postfix of j++. This will get replaced by 2, right? So actually we'll put this symbol onto this postfix of 2. What is postfix of 2? This position, right? We'll put this symbol over here, right? After this, j will get incremented by 1. You can see this over here. Now again we have I++. I becomes 6. Then we'll check this condition. Condition is satisfied. This time we have infix of 6. What is infix of 6? This is right parentheses. Now we'll put this character inside the symbol variable. Then again switch case will be evaluated. We have a right parentheses this time, right? Here we'll first pop the element out of the stack, right? We have to pop the element out of the stack. This is the topmost element of the stack. We'll pop this element out of the stack, right? And now we will put this inside this next variable. This means this character will be put inside next variable. Now we'll check this. Is this character equal to left parentheses? No, it is not the case. Therefore, we'll get inside this while loop, right? And here we will put next in postfix of j++. This means we'll simply put this symbol at this position, right? Definitely after this j becomes 4. And then again, we will pop an element out of the stack, right? Now this time this element will be popped, okay? And now you can see this, that next variable will receive this character. Now we can check. Is this character equal to this character? Yes. So we'll get outside of this while loop. This means we'll land at this point. This simply means that we'll break out of this case, and after this I++ will be evaluated, which means this becomes 7. Now again we'll check this condition. 7 is less than 9. Therefore we'll land at this point. And here this becomes infix of 7. What is infix of 7? This is star, right? We will put this character in this symbol variable. This is star. This is an operator. Therefore this case will be evaluated, right? And here we have while not is empty and precedence of stack top greater than or equal to precedence of symbol. We know stack is not empty, right? So we'll check this line of code. Is precedence of the topmost element of stack greater than or equal to precedence of the symbol? Let's check this. What is the topmost element of the stack? Topmost element is plus. We will check the precedence of plus. Let's check the precedence. We know that the precedence of plus is 1. So we'll receive 1 over here. After this, we'll check the precedence of the current symbol. We know this is star. So we'll check the precedence of star. We know this is 2. So we'll replace this by 2. 1 is not greater than or equal to 2. This becomes false. So we'll get outside of this while loop and we will simply push our current symbol onto the stack. Right? This is making sense? So above this, we will push this element, that is star, onto the stack. Obviously after this, break will be evaluated, will break out of this case. Then again, I++ will be evaluated. This becomes 8. Then again check this condition. This is 8 less than 9. Definitely this is true. We'll get inside again. We'll take infix of 8. What is infix of 8? Infix of 8 is the symbol. So we will put this character inside symbol variable. You can see this, it will get updated. We know that this is an operand, so default case will be evaluated. This means that we will put this symbol inside postfix of j++. We know this will get replaced by 4, and this means postfix of 4 will hold this character. You can see this over here. Postfix of 4 is holding this character. Then after this, j will get incremented by 1, right? Now after this, of course, I will get incremented by 1. This becomes 9. Now 9 is not less than 9, right? This condition is not satisfied. We are done with the traversal, isn't that so? 9 is not less than 9. So this becomes false. We'll get outside of this for loop, and this means we'll get to this point. While not is empty. Currently you can see this that we have 2 elements in the stack, right? And you can see this that the infix array is completely traversed up to this point. Isn't that so? We are done with this whole infix array. And we currently have these 2 symbols inside stack. Now we have to pop them out of the stack and store them in the postfix array. This is the last step required, right? So here of course this character will get popped out of the stack and will be pushed inside this postfix array. And after this, this character will be popped out of the stack and will be put inside this postfix array, right? And then after this, we can see this that last step is to put a \0 at the end of the string. So we'll put this \0 at the end of this postfix array. Isn't that simple? I hope it is clear to you how the infix to postfix conversion is done. This is the infix expression and this is the equivalent postfix expression, right? Now after this, we'll get back to the main function. This means we'll get back to this caller. And now we have to call the print function for the purpose of printing all the elements of this postfix array, right? And this means that we must have this piece of code where I have declared a variable I. And of course, we will receive this postfix array as well because postfix array is declared globally, right? We have this printf function. The equivalent postfix expression is while postfix of I. This means while postfix of I is not equal to \0, we'll continue and we'll print all the characters of the postfix array one by one. Otherwise, we'll get outside of this while loop. This means we'll get this output eventually, 795 minus 2 star plus. Isn't that correct? After this, definitely a new line will be printed, right? Now, let's execute this code in our favorite IDE. You can see the complete code over here. These libraries are included. Hash define max 100 is there. We have these arrays, stack, infix, postfix. We have a top variable which is initialized to -1, which indicates that our stack is currently empty, right? Then we have all these prototypes, which indicates that later on in our code, we have all these functions defined, right? We have a push function, we have a pop function. You can see the types are now changed. Here in this push function, we'll pass a character instead of an integer, and this pop function will return a character instead of an integer, right? Then we have isEmpty function, we have into_post function, and we have the space function as well. I'll tell you what this function does. Actually, I haven't explained this function in the presentation, but now I will explain what this function does. And then after this, we have this print function, we have a precedence function as well, right? So these are all the functions which we will see one by one. First, definitely we have a main function, right? Everything starts from the main function. I want you to focus on this main function. Here we have a printf function which asks the user to enter the infix expression. And here we have a getString function, that is getS function, which will receive the infix expression entered by the user. Here I'm calling 2 functions, into_post and print function. This we have already seen in the presentation, right? Then after this, of course, we have this into_post function. We have these different variables, char next, char symbol, I and j variables. Then we have this for loop which runs from 0 to string length of infix, right? And then we have the symbol equal to infix of I. Now after this, we have this line of code. If not space symbol, If symbol is not a white space, I have put this line of code. If not space symbol. What does it mean? I am calling this space function to check whether the symbol is a white space or not. And white space means a space character or maybe a tab character as well. Right? So here I am calling the space function for the purpose of checking if symbol is not a white space. And I've added this because it might be possible that the user will enter the expression with white spaces. I have to ignore those white spaces, right? That is why this line of code is added. This is a special function which checks if the symbol is a white space or not. If a symbol is a white space, then this function will return 1. Otherwise, it will return 0. Fine? Now the rest of the code is same. We know how this code works, right? After this, we have this while loop. This while loop is after this for loop. Okay? This is very important. Then we have the space function. Okay? If symbol is a blank space or a tab, you can see this over here. If the symbol is a blank space or a tab, then return 1. Otherwise, return 0. A simple function, right? Then we have this precedence function. You can see this, a very simple function, right? Then we have this print function. We have push function. Instead of integer, it will receive a character. That's the only difference. Okay. And then after this, we have a pop function. This function will return a character. Okay, you can see this. It returns a character. Then we have isEmpty function at the end. Now let's execute this code. Let's enter the expression which we have seen in the presentation and see whether it returns the correct postfix expression or not. This is the expression I have entered 7 plus 9 minus 5 into 2, and this is the expression so obtained 795 minus 2 star plus. The equivalent postfix expression is 795 minus 2 star plus. This works correctly, right? Let's execute this code once again. And this time I will add some white spaces in my expression. You can see this expression over here, 7 into 8 minus 9 plus 10. We have a lot of white spaces here. Actually, this is a tab. You can see this, our program is correctly producing the expression 7, 8 into 9 minus 10 plus, right? I hope the complete code is clear to you. Okay friends, this is it for now. Thank you for watching this presentation.